Hello and welcome to this video here, which is about how you can make your very first DIY LED strip project with WLED. Okay, just before we are getting started here, I just want to say it is of course a video about how to make your first DIY LED project, but since you also are gonna work with electricity, I think it is in its place to include a bit of technical knowledge same time. So let's get started. Let's start from top down with answering one question, and that is, what is WLED? WLED can be considered to be firmware, a software program, or it can be called a web server, or it simply can be considered to be an app. It is actually all of those things, but more than anything else, no matter what you call it, it is the app that you use to control your LED lights with. You also install WLED in the chip you choose to run it on. In this video here, we focus on using the ESP32, but we'll come back to that later on in the video. As a first thing I think you should do is actually here for some time, pause the video and then take your phone and install WLED. You install WLED from wherever you normally install your apps, whether that is Play Store on Android or App Store on iPhone. The next thing I think we should talk about is why you should make your own LED project. This is my take on why it's a good idea to do it yourself. I could make them any length I wanted, shorter or longer, cut them where I liked to cut them, installing them parallel, which means you have two LED strips that are doing the same. I could also go around corners. Extra to the LED strip installation itself, then I also found that the WLED app, it had a lot more possibilities. In my case, it also was a huge benefit that I could run them on Wi-Fi, and I didn't need a hub or anything special, but just the Wi-Fi router that I already used for my internet. Last but not least, it is also sometimes the case that the LED strips you can use for DIY projects, they are a better quality than those you can go out and buy pre-made. Let's look at the items you need for your LED project. At first, I will only introduce each item, and then later in the video I will speak of each individual item specifically. The first item you need should not be a big surprise, because that's the LED strip. It's from a brand called BFT Lighting, and the model is WS2812B. The next thing you need is an ESP32 chip to control your LED strip with. I use a version 4, But you can also use an older model. The benefit with the newer models is of course that they have improved and fixed bugs and so on. You need to power your LED strip and your chip. For that you need a 5-volt power supply. Also it needs to be in the correct size that fits with your LED strip power usage. The next thing here I actually won't cover in detail in this video here because I've made a separate video only about the level converter. However, I think it is at least a good idea to know about the level converter from start, so that's why it is included a little bit in this video after all. Then you will need a resistor that is put on the data line between the chip and the LED strip. The recommended size of the resistor is 62 ohms, but some people also experiment with resistor sizes from 32 ohms to 220 ohms. The next thing here, it might not be totally needed, but I still think it is a good idea to use a capacitor. The capacitor size that I use is 10 volts and 1000 microfarads. But I also have seen people using 16 volts, 25 volts or 35 volts even, and then 1000 microfarads. When it comes to powering your project, then it is important to use a decent thickness power cable that fits with your project's power usage. That is very important for both the safety and the functionality of your project. Also, it is a good idea to use a cable with 100% copper wires. Last but not least, you need a data cable that connects between your chip and the LED strip. The data cable should not be very thick. It is sufficient with a cable thickness that is the same as example jumper cables. And with that, we completed the list of items you will need for your project. Okay, let's now focus on and explain more details of each individual item. And let's start with understanding some of the different types of LED strips that exist. The best thing to focus on understanding is the difference between analog LED strips and digital addressable LED strips that we use in this video. That is where you find the biggest difference in LED strips regarding functionality and how you also install them. I actually see no reason to use analog LED strips except for the fact that they might be a bit cheaper. So we can also say, don't worry too much about this next information here. Installation-wise, analog LED strips, they need 4 wires. One is for red, another is for green, the third is for blue, the fourth is for voltage. So analog LED strips, they are controlled with a mix of how much power that is sent into the red wire and the green wire and the blue wire. And with that you can control what the colors are gonna be. But you cannot individually control each LED. All the LEDs are gonna be same color and brightness. With digital addressable LED strips, you usually only need to connect 3 wires. One is for voltage, another is for data, and the last is for ground. That is true for the LED strip we mainly use in this video here, and which also is shown on the image in the video now. However, there are some special addressable LED strips that has an extra data line and for that reason then needs to have 4 wires connected. The LED strip we are using in this video here with only red, green and blue LEDs can also show white light in a combination of red, green and blue. And to my experience, many times it is more than sufficient to use this one, the WS2812B. When it comes to the control of the digital addressable LED strip, then you have much more possibilities of controlling it. You actually have so much control that you can control each individual LED in the whole LED strip. In practice, it means that each individual LED, it can have its own color, brightness, or even just be turned off, separate from what all the other LEDs are doing. That again means that with the digital addressable LED strips, you can make animations, movements, or whatever you like to call it, unlike the ability of analog LED strips. Here now on the screen is shown WLED's official knowledge website, and also you can see the list of supported LED strips. Just a heads up here, you can buy the WS2812B LED strip from BFT Lighting and their shop in Amazon. Whether that's the German, the British or the American Amazon. Extra to that, I've seen they have a shop in AliExpress with a little bit cheaper prices. If, of course, you can wait for the extra delivery time, then that might pay off. Before we finish the topic here with speaking about LED strips, then let's have a look at the different versions of the WS2812B. First of all, you can get them in different lengths, 5 meter or just 1 meter. And the 5 meter is of course equivalent to 16.4 feet. I always get the 5 meter lengths because you can just cut them where you like, or even if you need more than 5 meters, you can actually solder the strips together. And I will actually show you how that's done later on in the video. Extra to the length itself, it is also important to notice how many LEDs you have per meter. They make a version that has 30 LEDs per meter and a version that has 60 LEDs per meter. Even you can get one in 100 LEDs per meter and 144 LEDs per meter. It is the same LED strip, but just the density is the difference, which can be important regarding your specific project depending on if you look directly into the LED strip or you put the light up against the wall. The one I'm using in this video here is 60 LEDs per meter, and with a diffuser that I will talk about after this, then it actually works okay, I think, with the density. You can also get the LED strip itself in both white and black color. And as a last thing, I think it would be good to mention they also come in different IP ratings, which is related to water resistance. Of course, the higher number of IP rating, the more water resistant it is. In all my projects indoor, I've only been using the IP30 rated LED strip, which also is easier to cut, and I find it good enough for indoor use. Extra to the items we listed earlier in the video, then you can also consider to use an aluminium channel for your LED strip. It will make your project look less TikTok teen-like and more professional and clean. It also helps on long term to prolong the life of your LED strip with keeping your LED strip cooler. The simplest way to install your LED strip channel is by drilling a hole in its back and then put a screw into the channel and into the place you want to mount it. Another advantage of the LED strip channel is that you can mount diffusers. That is really something I highly recommend to use when needed. It will make the light from the LED strip look more diffused, meaning it will spread out the light, making it look more soft, and it will disguise each single LED in the LED strip, making it look more whole. That is especially important when you can look directly into the LED strip. Let's now look a bit more into the details of the ESP32 chip. No matter which exact version you have of the ESP32 chip, then it is important to take a look at its pinout diagram. It also needs to be the diagram exactly for your chip. Usually you can get that from the seller. The point with looking at the diagram is of course to know what the pins of your chip are used for. If you look closer at the screen here and the chip I'm showing, you can see that there are small texts next to each pin of the chip, and that is those you need to get to know a bit about. It is also printed on the back side of the chip, and that actually also is where it normally is. It's only on the newer models of the chip where at the same time shown on the front side. Here now, let me just show a bit older chip I have laying around that I don't use anymore. This is a version 1.1, and the chip that I currently use, also which I use in this video, is a version 4. Despite this difference, then actually there is not too much difference between the pins of each chip here. But with that said, it is still important to look at the diagram for your chip because there can be differences. If we as an example go back to look at the new chip, then let's look at some of these pins here before we go into looking at the diagram. If you take a look at the pins at the bottom, then look at the pin that is furthest to the right side. It says 5V, and that of course stands for 5 volts. It is that pin you attach to the 5 volt voltage wire from the power supply. But don't worry about it, I will also show later in the video how to connect it. However, it is a good idea in short just to mention on some chips, sometimes this pin is called not 5V, but instead VIN. If you count 6 pins from the bottom right side, then you find a pin that says GND, and that stands for ground. So when you connect the ground wire from the power supply to this GND pin, then you should be able to, together with the 5V connected, to have power to your chip. And that of course is 5 volt power to your chip. Please don't by mistake mix these two pins up with one another, because then you might end up burning the chip and you'll have to go out and buy a new one. Let's now have a look at the pinout diagram, in this case for the ESP32 version 4 chip, the chip which we use in this video. If this is first time you see a pinout diagram, then I can imagine that it can be a bit overwhelming, but don't worry about it. It's gonna be more easy to understand than it looks like. And it is not everything that you see that we need to get into. Let's start with looking for what we already have been talking about, and that is the 5 volt pin, which you now can find on the bottom left side of the diagram. 6 pins up from the left side, there we again can find the ground pin that we also already talked about. As we talked about earlier, then it is these two pins that you need for giving power to the chip. I can add one extra information here, and that is it is always important to run the chip on the same ground as you have connected to the LED strip. But if you power the chip and the LED strip from the same power supply, then that should not be a problem. As the last thing actually regarding the diagram here, then we need to talk about the data line for the chip and the LED strip. The data line that needs to be connected to the chip, which also of course needs to be connected to the LED strip. And it is through that the signal from the chip, it goes to the LED strip to tell the LED strip what it should do. That data line, it needs to be connected to one of those pins that's saying GPO, and that's all the yellow pins. And then there also are some orange GPO pins on the diagram. As far as I can see, it looks like those are only input, so those should not be used for the data line. But with the yellow ones, we have plenty of GPO pins to choose from, and we actually only need one. Default, at least back in time, WLED, it used GPO2, but I think they recently have changed that to GPO16. So let's see if we can find those two in the diagram. Though before we do that, I just in short want to say you can always set it up in the app which GPO pin you use. If you count 5 pins from the bottom right side, then you can find GPO2. Again, if you count from the bottom right side, then this time you count 8 pins, then you will find GPO16. That is actually all we need to know to be able to connect the power cable and the data cable to the chip. But I just want to mention again that it is of course important not to use this diagram I'm showing in this video, but you should use the diagram that fits with your chip. Okay, just before you start wondering what I'm showing now on the screen, then a small story here, and that is I've had my fair amount of problem finding a good dealer that's selling the ESP32 chips, having to send the chip back to get a new one that also just didn't work. So after some time, I actually just took the plunge and I searched abroad from where I live, though still in my neighborhood, but though another country. So I found finally a shop in Germany that's called AZ Delivery. And to my experience, you can just trust them. All of the chips I've gotten from there, they just work first time out of the box. If you have found another shop that works for you and where you can trust that, all good. This is only just a recommendation for starting out. This shop here, they also have a shop in Amazon, Germany. The benefit of buying directly at their own website is that it is a bit cheaper. Plus, if you buy for more than 25 euro, then you have free delivery all over Europe. I just buy 3 chips each time of the ESP32 version 4, and with that then I'm above the 25 euro and I get free shipping. If you live over on the other side of the dam, then I'm sorry I don't have any personal experience with buying chips there in US. However, I've come across a lot of people who's using the Let Go shop, which is a shop in the American Amazon. So if I were there in US, I would definitely give that a shot. Let's now have a more detailed look on an important device that's gonna power your project, the power supply. There are different types of power supplies, everything from old phone chargers to more industrial-like power supplies and power bricks. No matter which type of power supply you're using, then it is first of all important that it is a 5-volt power supply that fits with the LED strip you're using. In this video here we of course use a 5-volt LED strip. The way we're gonna power the chip in this project, then it is also important with a 5-volt power supply. So the conclusion regarding what we have talked about this far regarding power supplies is that it is important that the things are fitting with each other, power-wise. Before we dive deeper into looking at the power supplies, I wanna do a little bit of easy math with you so you can make your project more safe from start. What I want you to calculate is the maximum power usage in ampere, which also sometimes is called current, but here we use the term ampere. Without complicating things, will hopefully not, then I might just here from start explain also what maximum ampere usage it is. That is when the LED strip is at 100% white and that it also is on 100% brightness, then it will be using the maximum power. When you then know after the calculation what the maximum power usage it is, then you can also know what size of a power supply you need. The calculation, as I said earlier, is actually rather simple. It's actually just a matter of multiplying two numbers and then divide that by 1000. The first number you need to know is the total number of LEDs you have in your LED strip, so you need to count them. When you have the number of LEDs in your LED strip, you need to multiply that number with 60 milliamperes. Here now, and I'm sorry for that, but I feel like I need to come with an extra information regarding this number 60. That is the maximum power usage of one LED for the LED strip type we're using in this project. Then as a result, you will of course have the total amount of milliamperes that your LED strip is using. But since we are interested with the total amount of amperes, then we need to divide that number with 1000. And with that you will have the final result of the total amount of amperes that your LED strip is using. Before we finish this calculation here, then let's look at some examples of the calculation. Looking at the first example here with a LED strip model that we use in this video and with a number of 108 LEDs total on the LED strip. Then let's do the calculation. So for this example we take the 108 LEDs and multiply that with the 60 milliamperes and then divide that by 1000 and we'll get the result of 6.48 amperes. Mind the number that is shown on the screen is a decimal comma and not as what is used many times in English-speaking countries, a decimal point. But instead we also just can round the number and say 6.5 amperes as the result. So as we first looked at in this power supply topic, then we need a power supply that is 5 volt, but then it can be 7 amperes big for this first example. It always needs to be a bit bigger than the maximum power usage. For the second example, let's take a LED strip with 18 LEDs total. Now here the calculation of this second example is now 18 LEDs multiplied with the 60 milliamperes and again divided by 1000. The result of that is 1.08 amperes, which of course rounded is 1.1 amperes. The power supply for this second example again and of course needs to be 5 volt. The size, if it can be 1.5 amperes, then that would be good, but if you can't get it in that size, then also at 2 amperes or at 2.5 ampere, it can also be okay. Let's put hands on the power supplies to take a closer look at their details. The first one here is an old USB phone charger. If we take a look at its backside, then the two most important things to notice is where it's saying input and output. Input, it means it is where the power supply, it gets power from the wall outlet in the house or apartment. Also under input, you can see it is saying 100 to 240 volts, which means it can be used in both US and in Europe. Next, then under output, you can see it is saying 9 volts and 1.67 amperes. If it only said that, then we could not use this power supply for this LED strip we use in this video. But since this power supply under output, it also says 5 volt and 2 amperes, then this power supply here is big enough to power the second example we calculated before with 18 LEDs. The next power supply here is also a USB charger, but unlike the other, then this one, it has 2 USB outputs. When that is the case, then you need to be aware if the ampere the power supply can deliver, if that is for both outputs or just for one. When nothing is mentioned, then it is usually the total combined ampere output it can deliver, meaning the amperes that is stated, such as in this case 2.4 amperes, that is for both USB outputs same time. Now let's have a look at this industrial-like power supply. If you have not seen these before, then they of course look a little bit more special compared to the USB charger, but the principle is the same. It also has a certain voltage it can deliver, and then the size measured in amperes. This specific one, again, like the others, delivers 5 volts. Again, because the LED strip we're using, it uses 5 volts. Compared to the USB chargers before, then this one is a bit bigger with now 7 amperes of power that it can deliver, which actually is big enough to power the first example we calculated with 108 LEDs. If you look furthest to the left, then you can see there is a place called L and next to it N and then a symbol. What you connect to L is phase, what you connect to N is neutral, and what you connect to where the symbol is, that is ground. But mind and be very aware of, these 3 I just mentioned, that is alternating power, or in other words, the power that comes out of your wall outlet from your house or apartment. So in Europe it is where you connect the 220 volts and in US the 110 volts. If you have ground in your house or apartment in the electricity, then it is always of course a good idea to connect the ground to the power supply. In my case, I don't have ground in my wall outlets, so I didn't connect it. Where it is then saying V plus and V minus, that is the 5 volt output that we use for the LED strip and the chip. Of course the V plus being the 5 volt and the V minus, that is the ground. Don't mix up these two. Also don't mix it up when you connect it in the other end to the LED strip. This last one we're gonna take a look at is also in the form of an industrial power supply. And it is a bit bigger than the last one we just saw. If we take the basics in short, then we can see this one takes from 100 to 240 volts for input. That is the alternating current, meaning it can both be used in US and in Europe. Output or DC power or direct current, there it is again 5 volts, but then able to deliver as much as 40 amperes of power. So it's able to power a bigger LED project with many LEDs, but I don't recommend starting out with such a project because it will complicate things a bit. But I will still come with hints in this video for future reference. Next, let's take a look furthest to the right side of the power supply. There we again can see it's saying L and N, that is still phase and neutral. It is for where the power goes in from your wall outlet. So that means it is here where the 220 volts goes in, or in US the 110 volts. And again, if your wall outlet in your house or apartment has ground, then it's also a good idea still to use that, which is the symbol just next to L and N. And as I said earlier, I still don't have ground in the wall outlets in my place. So I have only, in my case, connected the 220 volts to L and N. Now let's take a look at where it's saying V plus and V minus. Just like before, V plus is 5 volt and V minus, that is ground. But also I want to mention again, that is for DC power or direct current. That means that is the output which goes to your LED strip and your chip. In this case, this power supply, it has 3 outputs, which is only to make it easier to connect more cables to the power supply. It does not mean that each of these outputs, they have their own 40 ampere. They share the 40 amperes between all the 3 outputs. In a bigger LED project, there you many times need to connect more power wires to the same LED strip, and that is where these 3 outputs, they come very handy. Before we are totally done with the power supplies, then let's take a look at them with a multimeter to show what they're doing. You don't have to have a multimeter yourself. I'm only including it for the demonstration purpose. And I'm only using a cheaper one from a local hardware store. At first I've set the multimeter to alternating current or AC voltage. So we can have a look at the power going into the power supply from the wall outlet. Here you can see it's saying 232 volts going into the power supply, which is the same as many times considered to be 220 volts, just sometimes it can be a bit higher. So in other words, this is of course voltage in Europe. I'm also measuring where it's on the power supply saying L and N, which I just explained before. Now let's take a look at direct current or DC voltage. So we're gonna measure the output of the power supply, or the power that's gonna go to your LED strip and the chip. To start with, I'm gonna connect the black needle from the multimeter to the ground output of the power supply, which of course also then is where you're gonna connect the ground wire that's gonna go to the LED strip. Then thereafter, I'm gonna connect the red needle from the multimeter to the voltage output of the power supply, which is of course where you connect the 5 volt wire that's gonna go to your LED strip. And with that, we can read on the multimeter display that it actually also says 5 volt for the output. Let's now look at another important topic, cables. Cables are important for both the safety and the functionality of your project. So let's start out with having a look at some simple theory, but which is really gonna help you having a solid project. This paper here is actually the instructions that came with the power supply we looked at just before. And in these instructions they actually have included a table which is about cable thickness and which we actually are gonna look at. So that couldn't be better. Before looking at the details, I in short just wanna mention if as example there should be someone that don't care about cable thickness, I of course cannot imagine that's anyone watching my videos. But then in worst case, like example, the cable might melt if it is too thin a cable, and that can of course cause a fire risk. So it is, as I have said several times, it is a quite important topic. Though you are safe if you're gonna follow the instructions that I mentioned in this video and the table that I will explain here in a second. Let's look at the table. Up at the top left side, you can see it says rated current, and these numbers are in amperes. Amperes we looked at earlier when we made our calculation examples, and also when we looked at the power supply. Under you can see it says AWG, and it stands for American Wire Gauge, which is the cable thickness standard in US. For the rest of us, cable thickness is in square millimeters, or in this case mentioned as cross-section of lead. If we go from the left to the right side of the table, then let's start with the smallest example, which is 6 amperes. And that means the maximum power usage of your project should only be 6 amperes. So that means of the calculation examples we made earlier, then it is actually only example 2 that is small enough for going under 6 amperes. But for that example, then it's okay to use a cable thickness of 18 AWG, or in Europe is 0.75 square millimeter thick cable. If your project uses more than 6 amperes in power usage, then you need to look at the next example, which is from 6 to 10 amperes. And there, if it fits with that, then you can use a cable thickness of 16 AWG or 1 square millimeter. That is actually where the first example we calculated earlier, it can fit in here, which used 6.5 amperes total when we rounded it. I take you now have gotten the hang of reading this table here, but I will still come with one more example that is a little bit to the side of a video that is about starting out on making your first LED strip project. So don't worry too much about the example I'm gonna come with here, which is a little bit more advanced, but I'm still including it because it can be good to know for future reference. So let's look at the example where we actually just gonna calculate like we did earlier. But unlike earlier, I'm not gonna show the calculation on the screen same time. So I'm just gonna take it here with words. So let's first of all say we have a LED strip that is 600 LEDs, and to know the maximum power usage in ampere, we need to take 600 times 60, which is 36,000, and then we need that in amperes, so we divide the 36,000 with 1000, and then we'll have a result of 36 amperes. With that, you maybe have figured out why I earlier showed that I have a 40 ampere power supply, though that's not important. What though is important is that the maximum power usage of 36 amperes, it fits in with the numbers mentioned in the right side of the table, that is between 32 to 40 amperes. And with that we need to use quite a big cable, that is 8 AWG or 6 square millimeters. For now, this is the same as we already talked about regarding cable thickness. In practice, it is a bit of a different story, because despite you can use such a big cable that we talked about here for this example, then you cannot solder that cable directly onto the LED strip. It is just too big. So you need, for a shorter distance, quite short distance, to have another cable that you solder onto the LED strip, and then you connect that to the bigger cable. So with that, then you have solved the first part of the problem. You can do that as long as you keep the thinner cable short, and that maybe is around 4 inches or 10 centimeters. But mind, when I say it is a thinner cable, I don't mean it is a very thin cable. I just mean it is thinner than the big main cable, and that it is possible to solder onto the LED strip. For now, we have solved the safety concern regarding this bigger LED strip project. We though now still have a functionality case to look at, and what I mean with functionality is the behavior of the LED strip. In practice, that means if you only power the LED strip from the start of the LED strip with this bigger cable and including the short, thinner cable, then you run into actually another problem with such a big LED strip. And that actually is that the LED strip, it cannot get power enough, like probably from the middle of the LED strip and all the way to the end of the LED strip. And that problem is also called voltage drop. The LED strip is simply just not getting power enough. Without forgetting this table here, then let's have a look at what voltage drop it looks like in practice. You can see in this video clip here that the more we go to the end of the LED strip, that is to the right side, then the color is changing, and that's because it's not getting power enough. To solve this problem with voltage drop, what you do is making use of a method that's called power injection, which is a matter of just putting more power into the LED strip at more points of the LED strip. How many places you need to do that is a matter of how many LEDs your LED strip it has. In this example here with 600 LEDs, I'm gonna say it's okay to put power in the start of the LED strip, then again in the middle of the LED strip, and in the end of the LED strip, which means that is 3 power injection points. You can do that with running the main big cable alongside the full length of the LED strip to the very end. And then you just take some smaller cables, as we already talked about, putting that into the LED strip from the middle and then in the end again. Then you will have 3 injection points, including the start. However, there is actually another way to do that, and that is by running 3 cables from the power supply to each of the 3 injection points of the LED strip. So that is instead of running one big cable along the full length of the LED strip. And that is actually the method I prefer, to run 3 cables. So let's say we use 3 cables instead of 1 cable, which means we can take the total power usage and divide that by 3. In our example, it means we need to divide 36 with 3, and that of course gives 12 amperes. So using 3 cables, that suddenly means that it fits in the table where it's saying 10 to 16 amperes, which means we can use a much smaller cable that is 14 AWG or 1.5 square millimeter. Again, that is when we use 3 cables going from the power supply to the 3 injection points of the LED strip. I will later in the video show how you solder cables into the middle of the LED strip for power injection. Just to finish this topic here with power cables, then you can here see the difference between the original cable that's soldered onto the LED strip and then a 14 AWG or a 1.5 square millimeter cable. Extra to that, as I said earlier in the video, then it's a good idea to use a cable that consists of 100% copper. For now we've been looking at all the items that's powering the project, but we are still missing out on some few items, where I now in general would say that these items are gonna help with making your project run better. It might be first time you hear about these items, and it also might seem more related to an electronics project than a LED strip project. Despite that, then they are actually most of them quite easy to use in practice. That's why I include them and recommend them, but also because it will make your project run more stable and better. The first thing we're taking a look at here is the level converter, and it is actually the most advanced thing of these last items. But the good news is that you might actually not need it for your project, and also that I have made a video especially only about the level converter, if you need to know more. In short, I can say there seems to be two opinions about when to use the level converter. Some are saying that you need it for all your projects. Others are saying it's only in longer LED strips with more LEDs where you need it. In my own experience, I have actually only used it in a longer LED strip project where I have more LEDs, and I used it to counter some flickering that I could not get rid of in any other way. But let's just finish with saying in short what the level converter actually is doing. The level converter is transforming one voltage to another voltage. For the chip and the LED strip we use in this video, then there actually is a voltage difference on the data signal that they use. The ESP32 is actually outputting 3.3 volts on the data signal, while the LED strip, it works best with 5 volts signal. And that is why sometimes it can be a good idea to use a level converter to make the 3.3 volts into 5 volts data signal. There are different types of level converters. The one I'm showing on the screen now we can call an I2C type of level converter. Despite it might be cheaper and kind of easy to understand, then it might not be the very best to use. Another level converter is this one from Texas Instruments, and it just seems to work better. Despite it costs a little bit more and also maybe is a little bit more difficult to understand how to connect, then I would say it's worth it, and it's the one I'm using. It also is the one I'm explaining how to use in another separate video. Now let's have a look at the resistor. Some people recommend that you always use the resistor, while others are just gonna say that it works without. There even can be different opinions about what it technically does, going from current limiting and thereby protecting the LED strip. Others suggest that it helps against ringing, where the data signal otherwise would travel back and forth. No matter the technical details, then I'm actually always using a resistor on the data line between the chip and the LED strip in my projects. To my own experience, I've seen it helping a bit with if you experience flickering in your project, but that also depends on the size of the resistor that you're using, where I myself actually have experimented a bit with the sizes to bring down the flickering. I didn't in my own case totally get rid of the flickering just with the help of the resistor, but it helped it a bit. And that's where what I said earlier, that I started using the level converter to totally get rid of the flickering. Back to the resistor. If you start out using the recommended 62 ohms, you are in a good place to start with. Ideally, the resistor size is actually depending on your specific project, like the data cable's thickness or the length of the data cable. If you do start to see that you have a problem like flickering after using the recommended 62 ohms, that though will work in many cases, but then you can start using a different size resistor, maybe from 32 to 220 ohms. Last but not least, let's have a look at the capacitor. Technically, the capacitor is helping with the waveform of the electricity to make it better. Also, it might help where there suddenly changes in the demands of the power of the LED strip. Some argue if it is really needed or not. I actually always use it in all my projects, and I even use it for each injection point if I have injection points. The capacitor size that should be used is 1000 microfarads. The one I'm using is 10 volts. If you can't get a 10 volts capacitor, then you also as well can use a 16 volts, 25 volts or even a 35 volts capacitor with still 1000 microfarads in size. You connect the capacitor near the LED strip between the 5 volt and the ground wires. The capacitor has two legs, and it is one of these legs that needs to be connected to the 5 volt wire, while the other needs to be connected to the ground. It is important which of the legs you connect to 5 volt or ground. One of the legs is usually shorter than the other, and on that side where the leg is shortest, there also usually is a minus symbol, which means it is of course the leg that is on the side of the minus symbol that needs to be connected with ground. First part of connecting everything is by using the soldering iron. So let's get started. Let's start with connecting the wires to the LED strip. Before we start doing that, then let's have a look at exactly where you connect each wire. Here where I'm now pointing on the LED strip, that is where you connect, or more correctly solder, the 5 volt wire from the power supply to the LED strip. Again, I cannot mention this enough. It is important to double check that it in fact is the 5 volt wire from the power supply that you connect here. Next, here where I'm pointing now, that is where you solder the ground wire from the power supply to the LED strip. You can also see on the LED strip it says D and D for ground. Last but not least, here in the middle, that is where you connect the data wire from now the ESP32 chip. You can also see nearby it has an arrow, and that means that is the direction the data signal is traveling. Also, it means it is just before the arrow where the data signal is gonna go into the LED strip. If you had connected the data signal from the opposite end, like against the arrow, then that would not work. So you need to connect the data wire before the arrow, pointing away from the data wire. Let's now start the soldering of the wires to the LED strip. For now, I also just want to say you don't have to have a very expensive solder iron. The one I have is a little bit more advanced where you can adjust the temperature, but that is not strictly needed. At first I'm just heating up the cover pad for a shorter time, so the solder tin better can attach to the pad. Next, I'm of course just soldering the tin to the pad, and I have to repeat this process for all of the 3 pads. Let's now actually solder the wires to the LED strip. I'm starting out with soldering the red wire, which is the 5-volt power wire, to the LED strip. Just mind there is differences between the color standards of power wires between US and Europe as example. And also you shouldn't just rely on the color of the wires, you need to see where it's connecting to. Here now the 5-volt wire is soldered onto the LED strip. Little bit more difficult to see, but here now I'm soldering the ground wire to the LED strip. Last, let's solder the middle, which is the data wire. Here I'm using an extra accessory that is a screwdriver to hold the wire while I'm soldering, so I'm not burning my fingers. And with that we have soldered the 5-volt, ground and data wire to the LED strip. Because we already talked about injection, then I just wanted to show how to make such an injection point, like example here in the middle of the LED strip. I'm showing it so you can see what power injection is in practice. When it comes to soldering, it's the same as we already did. So for the power injection, I only need to solder the 5-volt wire and the ground wire to the LED strip. For the LED strip we use in this video, then there is no reason to use power injection, because it only has a few LEDs. When needed to put the power injection on in the end of the LED strip, then it's of course done in the same way. Here's the final result of the power injection. Before continuing with the main LED strip project, then I think there's still a little bit extra things that can be good to know. In this case, let's have a look at where you can cut the LED strip. In the factory, when they are making LED strips, then they're actually only making 1 meter lengths, and then for the longer length, then they are soldering the 1 meter lengths together. When you are cutting the LED strip, then you should not do it where these solder joints are made. Instead, you should cut the LED strip where only the copper pads they are, and then you can see there is a thin white line going through the middle of the copper pads. That's where you should cut it. No matter if in the factory it is a machine or a human that's soldering the LED strips together, then let's try to do the same. It can be very useful for when you need to make a LED strip longer than it originally is. Right now I'm just lifting up one part of the LED strips, so you can see it in fact is 2 separate LED strips here on the table. Like the other soldering I did, then I'm actually just here first heating up the pads so the solder tin it better can attach to the pads. Now I'm just applying the solder tin so it's going on both copper pads. We can say like a bridge over the cut I made, so the 2 LED strips will be connected. And I just need to repeat this process for the 2 last pairs of pads. Here now is the result. The two LED strips are joined together. After going through these subtopics with power injection, cutting a LED strip, soldering two LED strips together, then let's go back and have a look at the main LED strip again. And let's focus on the data wire, which we need to do a bit more soldering with. Before starting the soldering, then I'm here at first just twisting the end of the data wire onto the resistor. After heating up the resistor and the wire together, then I'm just applying the solder tin to both. So all I need to do now is just to do the same in the other end of the resistor, with here twisting a shorter extension wire to the resistor. And then hereafter, of course, also gonna solder this end too. Here you now have the final result with having soldered the data wire to the resistor. It is of course a good idea to cover up the resistor and the solder joints with tape, but had I done that, then we couldn't have seen it. Okay, let's now solder the wires to the ESP32 chip. I will start with soldering the data wire onto the GPO2 pin of the chip. Though mind, that might not be the default pin that the WLED is using. So you can actually instead here use GPO16. Unlike the pads before, then these pins then need a little bit longer heating time because they are thicker. Else it is of course much the same, and I'm also here now applying solder tin to the pin. Now just soldering the data wire onto GPO2 pin. Here now just the result of having soldered the data wire to the GPO2 pin. Now let's solder the 5V power cable to the 5V pin of the chip. Like many times before, then I'm first heating up the pin, whereafter I'm putting the solder tin onto the pin. Because I'm using a little bit thicker cable, then I also need to put solder tin onto the cable. It's best to not use too thin a cable for powering the chip. Now I'm just soldering the power cable to the pin of the chip. Now the time has come to solder the ground wire to the GND pin of the chip. Can you guess what I'm doing now? No, I'm just kidding. I'm just applying heat to the pin and as usual applying the solder tin also to the pin. And again I'm just putting solder tin onto the wire. Despite already announced, then it is first now that I solder the ground wire to the GND pin of the chip. Now let's look at the result of having soldered the 5V power wire to the chip and also the ground wire to the chip. With that, we are actually finished with the soldering part of the project. Here in the end, I'm just using some electrical tape to isolate the solder joints. Some are using heat shrink tubing, and that also might be easier to use, but for me, that's gonna be next time. Just a proof of that I have not fallen to sleep. I also hope that you have not. But then I want to mention that I just finished here now putting tape on the ground pin of the chip. Now we have finished putting tape on the last pin of the chip, which of course is the data soldering joint. Last but not least, we also need to isolate the data wire where we have soldered the resistor onto. That's it. Now all the solder joints are isolated. And we can start to look at how to install WLED in the chip. Before connecting the chip to the computer, then a precaution. You should always disconnect the LED strip and the power supply from the chip. That's because when you have the LED strip connected, it can require too much power for the computer's USB port. And it can be quite an expensive mistake if the computer's USB port is damaged. The USB cable that you use should be a micro USB cable that also can transfer data. Now with the chip connected, let's start up the computer. And begin on the installation of WLED. To install WLED, you first need to start up a web browser on your computer. Then you should go to the web address install.wled.me. Then the installation page for WLED, it should load from where you can install WLED into the ESP32 chip. If you cannot connect to the chip, which I will show in short, then you can click on this link where it's saying no device found. Often the case that your USB cable doesn't support data transfer, or that you don't have the correct driver installed. Moving on, then in this drop-down list, you can see the different versions of WLED that you can install. At the time of this video here, I'm just going with the newest version, which is a 0.15.0 version. Down under, you can choose what we maybe can call sub-versions. That is a plain version, Ethernet, or for an older ESP32 chip, which though seems just for testing. There's though one thing missing in these options here, and that is the audio reactive version, which if you have wanted that, you would have to have chosen a bit older version, which in this case would have to have been a 0.14.4 version. But let's just go ahead with the newest version and the plain one. After you have selected the version and the subversion you want, then go ahead and click the install button. It is now you connect with the chip with choosing the correct driver and USB port. In my case, I only have one port, which is COM3. Next comes a pop-up window where you just choose Install WLED. Now the pop-up it changes content and it's asking if you wanna install the version you selected before and that all data will be erased. Before continuing and clicking Install, I always hold down the boot button on the chip. I'm holding down the button while I with the mouse click Install. And then I keep holding down the button into where it on the screen says preparation. And then I'm like holding it 10 to 15 seconds or the like. In the past, I held down the button all the way into where it started saying installation on the screen and where you can see it starts to count in percentage of how much you have installed. I'm not doing that anymore, but that's what I did in some older videos. It seems now the installation process takes longer time before it starts. In this case, for this video, it took 3.5 minutes before it started. So you need to have a bit of patience while you're installing WLED onto the chip. It is first now where the installation for real is starting, and it is also here where the installation progress is shown in a percentage circle that I spoke about before. Finally, it's saying installation complete, and WLED is now installed in your ESP32 chip. Click Next, and it starts to scan for Wi-Fi networks that is within the reach of the chip. If you have nearby neighbors, it might have found more Wi-Fi networks than just your own. So just find your own network in the list and after that enter the password for it. If you cannot find your own Wi-Fi network in the list, then it's important to know the chip only supports 2.4 GHz Wi-Fi network. So you need to enable your 2.4 GHz Wi-Fi network before it's shown. If you have found your network in the list and you have entered the password for it, then click Connect. The chip itself will now try to connect directly to your Wi-Fi network. When the chip successfully connects to the Wi-Fi network, it will show a new pop-up screen where it up on top says Visit Device. Click on that. What we see on the screen now is WLED's web interface, meaning that's of course how WLED is looking through the browser on the PC. I like to turn off the PC mode, which just only changes the look of WLED here in the browser, and making it look a little bit more like the app on the phone. Let's now go into the settings of WLED and set up the chip to be ready to be connected to the LED strip. And we'll go into LED preferences. The first thing I think you should notice is up at the top of the screen, just under the headline, it says Total LEDs 30. That is the default amount of LEDs that WLED is set up to. And just under it comes with a recommendation of the size of power supply you should use. When the LEDs are on brightest white, then the recommendation is 2 amperes. Though for most effects, it also says that 1 ampere is enough. If you try to do the calculation we made earlier in the video, then you will come to about the same result with the required 2 ampere power supply for these 30 LEDs. The first setting here is actually a setting that I'm not myself using very often because I prefer to have a big enough power supply. But now that it is here, then let's talk about it. It is the setting which enable automatic brightness limiter. What it does is that it automatically limits the power use of each light effect in WLED. As example, some effects might require more power and for that reason is limited more, while effects that's not using a lot of power, they are limited less. It's limiting by calculating how much the power use is. As example, it can maybe limit the brightness of the LEDs, how much light they output. So when this brightness limiter is enabled, it makes it possible to use a smaller power supply than you normally should use. Together with this setting, then there is another setting that belongs to it, which is called maximum PSU current. That is where you set the size of your power supply, but I always recommend setting it a little bit less than the size it actually is, because that's in general just a good idea regarding power supplies. So let's say that your power supply actually is 2 amperes, then just notice here the number should be in milliamperes, meaning you need to multiply with 1000 to get to milliamperes. So that means if you have a 2 ampere power supply, then multiply that with 1000, that is then 2000 milliamperes that you need to enter here. And then maybe just say 1800 to make it a little bit less. If you enter 2000 milliamperes, which is the same as 2 amperes, or if you only entered 1800 amperes, which is the same as 1.8 amperes, then it will maximum use this amount of power, no matter how many LEDs that you have in your project. There is even a third setting that also is related to the automatic brightness limiter. This setting here is related to milliampere usage per LED. It is also where we earlier in the video, when we calculated, we used 60 milliamperes as maximum power usage per LED. Unlike the number we used, then WLED is using 55 milliampere as maximum power usage per LED. The reason we used a little bit bigger number is because we're just a little bit more conservative in our calculation earlier, just to be on the safe side. Unless you're using a special version of the LED strip, then there's no need to change the number here. Though it could be you, as example, have been using the Eco version of WS2812B, and then you would have to choose 35 milliamperes instead. But I don't recommend using the Eco version because it is not as good as the standard version. All of this was related to using the automatic brightness limiter, but let's try to turn that off, and then we will have a little bit less settings on the screen, which now is not anymore related to the automatic brightness limiter. The first setting we can look at actually also was there before, but let's look at it now. It's just a list of supported LED strip models, and you normally would not have to change a lot here, especially if you are just using a WS2812B. Then just choose WS281X. Next is the color order, which is related to how the LED strip is controlled, and it also relates to the model of the LED strip that you have chosen. For WS2812B LED strip that we use in this video, then just leave it at the GRB. Now let's go down and have a look at the lengths, and that is of course the length of your LED strip counted in how many LEDs you have in your LED strip. In the project for this video, we have 37 LEDs in the LED strip. Next, also important to set the GPIO data pin that you use on the chip. Also here we can see that the default actually are using pin 16 that we kind of suggested earlier in the video that they might have changed it to. Since I used GPO pin 2, then of course I need to change it here. Despite there are more settings, then we actually have looked at all the settings that we need to look at. The rest of the settings are more special settings that you might actually not even need in the future, but also it might be that you just only need a few of them. But because of that, then I'm not gonna talk about them in this video. The only thing that's left is finding the Save button that is located at the bottom of the screen, though it also can be found at the top. So when you press the button, then all the settings will be saved onto the chip. So that's actually all the technical settings that we need to do to get the project up and running. All we need to do now is shut down the computer. And unplug the ESP32 chip before we can go into the next topic. Let's now start on the fun of putting everything together, and then in the end hopefully see that it is all working. Just like the other topics, then there is a little bit of knowledge that is good to know before we start. The way in this project that I connect all the wires together is by using something that is similar, the more known Wago connectors. Just the one I have, they are a little bit cheaper ones, but I find them good enough. The reason I'm using these connectors is because they are very fast and easy to connect wires together without the use of any tools. Also, if you need to change the software in the chip, then it is very easy to disconnect the chip from the rest of the project. Though there also are other ways to update the software in the chip than with the use of a USB cable directly. But back to the connectors and a little bit important information, which is if you're used to the older classical screw connectors, which is shown an example of in the screen now, then mind and be aware of that these connect different types of wires side by side, such as you can see in the image where there is a blue wire next to a brown wire, but which do not connect to each other. And then when it comes to only one connector, it leads the electricity straight through to the other end, so that you need to have the same type of wire put into both ends of one connector, which also is shown in the image. You can of course still use these types of connectors, but if you're new to the connector that I use in this video, then there are a few things that you need to be aware of, which is different. The Wago-like connectors that's used in the video here are different in that way that they connect the same type of wire side by side, like the connection takes a U-turn and goes back out the other hole of the connector. You can also see in the image that there's only two blue wires connected. So do not put two different types of wires into these. You can experience to short circuit whatever you have connected to it if you do. So don't do that. Let's start with connecting the data wire, which is between the chip and the LED strip. We'll of course use the connector that we spoke about before. Be sure to check that it actually is the data wire from the chip. And also be sure from the other end that it actually is the data wire from the LED strip that you connect. Next, we're gonna use a shorter power cable that's gonna power both the chip and the LED strip. And we start with connecting the 5-volt wire from the LED strip. And in the same side of the connector, we also connect the 5-volt wire from the power cable. I just pull a bit in the wires to check that they are proper connected. Notice there's one lever open because I only put in the 2 wires into one side. With a new connector, we just do the same, but now with the ground wire from the power cable and the LED strip. So now I just insert the ground wire from the LED strip into the connector. And in same side, I also insert the ground wire from the power cable. Now we need to connect the capacitor, and if you remember what I said earlier in the video, then the capacitor, it has a voltage side and a ground side. And it also needs to be connected between the ground and the 5-volt wire. The side of the capacitor with the minus symbol on, that is the side for ground, while the other side that usually has the longest leg, it is for connecting to voltage. Same time I connect the power wires from the chip, and I start with the 5-volt wire. Then I just insert the voltage leg of the capacitor together with the wire. And now we just need to do the same with the ground side and the ground wire from the chip. And also, of course, insert the ground leg of the capacitor. As you can see here in the close-up, then the left connector, it only has red wires connected, which of course is meant to be for 5 volt. Same time it has the voltage leg connected from the capacitor. Opposite the right connector, it only has ground wires connected to it, and of course the ground leg from the capacitor. Now the only wires we have left to connect are the wires from the power cable, and they need to be connected to the power supply. Just before you blow up the LED strip. No, I'm just kidding. But then it is a good idea to double check the connections. See if the 5 volt wire, it connects all the way through to the LED strip's 5 volt input. And see if it also connects through to the 5 volt pin of the chip. And now also check on the power supply the correct place to connect the 5 volt power wire, which of course should be the 5 volt output, where in my case it's saying plus V. So just take the 5 volt wire from the power cable and insert it into the power supply. Tighten the screw. Now insert the ground wire, but be sure to check that it is the ground wire, and also that it is the ground output of the power supply that you connect to. Then just one last step. Make sure it's firmly connected. Now we can for the first time power on our project. Just plug in the power supply to the wall outlet, though in my case it's a power strip. Your LED strip should light up in yellow and in 50% brightness, because that is the default settings when you turn on the chip for the first time. Then take your phone and go into WLED app. Click the plus symbol up in the right corner of the app and click the button up at top where it says Discover Lights. After only a little bit of time, it should come and say that it has found your light. In my case, I have already named it WLED First LEDs. Whatever it is named in your case, then just up in the right corner, click on the check mark. If you also want to rename your LED lights, then let's take that now. Select your LED light. Up in the right corner, choose Config. Then go into User Interface. Up at the top, next to where it says Server Description, is where you can type in the name that you like to give it. And then finally just press save. And go back out of the config again. And you should see in the list that it is renamed. Now I'm just playing a bit around with the dimming fader to see that WLED is connected with the LED strip. For demonstration purpose, then I'm just changing the colors a bit. And going into different animations of WLED. Okay, that is it. We are near the end, but don't miss out on the very end.
Although it's over now, don't let it get you down. We'll be back around. For now we can feel some sorrow. A new day, it starts tomorrow. We'll wake up, new dreams to follow. A new goal and brand new motto. One last time, let's live for something. I can feel my blood, it's rushing. This ain't goodbye, we'll be back someday. And we will find our own way, take control of our fate. And like a car with no brakes, crash and learn, make mistakes. And we'll be back one day. We'll be back one day. We'll be back one day.
Please give a like and a subscribe. Thanks for watching.